All right, in this section 4-6, we're looking at the properties of logarithms. And so the first thing that we come to is the change of base formula. And the reason why we have a change of base formula is most of the calculators, a lot of them, only have two keys for logarithms. And that's one with logarithm base 10 and one for base e. So if you're trying to evaluate something with a different base other than those two, the only way to do it on one of those calculators that doesn't have a way to change the base is the change of base formula. And then you can change it to base 10, which the calculator can use. You can change it to natural log, which the calculator has a button for. Or you can change it to whatever base you want to, which is useful sometimes when you're solving equations and whatnot. And on the calculator that's typically on your phone, if you look at that, okay, you've got a log, but that's base 10, and you've got a natural log. So there would be no way to evaluate in the calculator like log base 2 of something, right? Okay? Unless you change the base. Now, how does the change of base formula work? Okay, it'll look like this. All right? So what you can do is, if you've got a log of any base, whatever the base is, you can write that as log base of your choosing. You choose what base you want here, and then it would be log whatever base that is of x over log base b of a, the previous base. Okay, and so those two would be equivalent. And likewise, you can change that to base 10 or base e and get the natural log. And really, honestly, you don't even really need these two formulas, because this formula is just the same with this one where the b is 10, where the b is 10, right? And this formula is the same as this formula where the base is e, because base e is natural log, right? So these two are really just variations of this formula, or specific values of b for this formula, okay? So that's the main change of base formula, all right? Let's see here. What else do we need to look at? Okay. All right, so examples of using the change of base formula will be kind of like this. And so if I wanted to change this one to base 10, then I could write it as log base 10. And remember, you don't even have to write base 10. If you don't write any base, it automatically means 10 of this number, right? The x, which is 25, over log base 10 of this number, the a, which is this base, which is 4. Okay? All right? And so now we've got it in a form that we can evaluate on these other calculators. All right? So like, for example, on this one, now I could write this as, let's do it on Desmos. I could write it as log, and I don't even have to write a base 10, because if I don't write anything, it's automatically base 10, and then go log of 4. And so when that divides out, that's 2.322. Okay? And if I wanted to turn that into a natural log, then I could. That would be the natural log of, and so remember, it's the natural log of the x number, which is 25, divided by the natural log of the a number, which is the base. In this case, we're talking about 4. And so if I divide that out, then we should get the same answer. Let's see if we do. Natural log, oops, I need my division. Natural log of 25 over the natural log of 4. And it does give us the same answer, 2.322. All right? Okay, so that change of base formula would allow us to evaluate this problem, log base 4 of 25, on a calculator that doesn't allow us to change the base. Now, like for example, the one that typically comes on your phone. Now with the Desmos calculator, it doesn't matter because Desmos does allow you to change the base by going to this button right here. Desmos calculator will allow you to change the base. And so if I just change that to base 4 and base 4 of 25, and then so we can see it's 2.322, the same thing that we got when we did the change of base formula. All right. So like I say, change of base formula is useful when you are using a calculator that doesn't have a function that will allow you to change the base, like typically what comes on most calculators. Or there are times when you're solving equations with logarithmic functions that it's helpful to change the base. Okay. Let's try the next one. Okay, if I wanted to evaluate this one, I could go change it to base 10 if I wanted to, log base 10 of 12 over log base 10 of 2, and we could divide that one out. Get my fraction, go back to log of 12 divided by the log of 2, because remember, if I just pick log, it automatically means base 10, and so that's 3.585. We could change it to natural log as well. It could be the natural log of 12 over the natural log of 2. So, whoops, forgot my fraction again. I'm going to clear that off and start with the fraction. Go back, natural log of 12 over the natural log of 2. And again, we did get the same thing, 3.585. And so the question is, what if I change it to a different base? Would we get the same thing? Let's look and see. So what if I changed it to what if I changed it to log base 6 of 12 divided by log base 6 of 2. Would we get the same thing? Yes, we do. 3.585. Okay, so it doesn't really matter what base you change it to. It's still going to be equal.
At this time, please dismiss all bus riders and drivers to the South End.
You ride the bus. I'll see you next week. Bye, guys.
No.
So the next thing that we come to here is some properties of logarithms. And so first one's the product property here. So if you've got the log base A of u times v, then that's equal to the log base A of u plus the log base A of v. So you can take these two things that are being multiplied together as a product and separate them with a plus. All right. In a natural log, it would look like this. Natural log of u times v is the natural log of u plus the natural log of v. Right? So if it's multiplied together inside a logarithmic function, it can be separated as the sum of these two. Okay. Quotient property, if you're dividing, right? If you're taking the log base A of u divided by v, if you're dividing, you could split those into a difference. Okay. Same thing with the natural log. Split these into a difference. Then you've got the power property. So if I'm taking log base A of u to the n power, then you can rewrite that with this exponent multiplied by the front of the entire function. Okay? And in natural log, here's the way it would look. Natural log of u to the n power is equal to n times the natural log of u. So product property, separate them into sums. Quotient property, take the division and separate them into differences. And then power property, you can take the power and multiply it by the front of the function. Okay, so we're going to use these properties now to simplify some logarithmic expressions. Okay, so we want to use the properties, and it says to expand the expression. So we're going to expand the expression into multiple terms. So we're going to expand this out. This is a division, right? So I'm going to use the quotient property, which says I can take this and write it as the difference of log base 10 of t, and since it's a quotient, it's going to be difference minus log base 10 of 8. All right? So we've taken it and expanded it out now into two terms by using the quotient property. Okay? The next one, we need to expand this. And so on this one, we're actually going to use two properties. We're going to use the product property because these are all being multiplied together. But we're also going to use the exponent property because two of these have exponents other than one. So what we'll do is we'll take it out into sums, and it'd be three different sums because I got three different products. And when we get to B and C, we're going to take that exponent and write it out in front. And so really what this is going to look like is log base 6, all right, of A plus 3, start with the 3, log base 6 of B plus exponent first 2 log base 6 of C. Okay, so that's how we would express expand out this particular expression. Okay? And so the next one that we're looking at now is one where we have the natural log of the square root of a quotient. Okay? Now what we're going to do is we're going to rewrite that square root as an exponent. And so the first way we'll rewrite it is we'll say this is the natural log of the square root of x squared over the square root of y to the third. So just expand that out to the square root of the top over the square root of the bottom. So we're still good there. And now we can write that as the natural log of, well, the square root of x squared is x. So I'm just write that as x over. Now, the square root of y to the third can be rewritten as y to the 3 over 2 power. Because remember, when you have a fractional exponent, the bottom of the fraction is the root. The top of the exponent is the power. The bottom of the exponent is the root. So this would be like the square root of y to the third is the same as y to the 3 over 2 power. Whatever root you're taking goes to the bottom of the fraction.
At this time, please dismiss walkers and bike riders to leave from the front or side exits.
Okay, and one more step. I can now use the product rule, or excuse me, the quotient property, and I can use the power property. So now I can expand this out into the natural log of x minus, because it's division, I can take this exponent out front, 3 over 2 natural log of y. All right? So I'm just using these properties to expand out these expressions. This last one took a little bit of simplifying first to get it to a form that we could expand out, right? So we had to take that square root and write it out as just single powers, right? I had to take the root and write it into an exponent, in other words. Okay, so anytime you've got square roots in these, you want to simplify it and rewrite the square root as an exponent, or whatever root you've got, third root, fourth root. So if this was third root instead of if this was third root instead of square root, then there would be a 3 under here instead of a 2, and then that would just be y. If this was fourth root, then it would be y to the 3 over 4 power, and so on. So again, if you've got roots, you want to take those roots in your expression and rewrite them as powers, as exponents. Okay? Then you can go ahead and use the properties of the logarithms to finish it. Okay. All right, a couple more. And on this one, we're kind of going backwards. We want to use the properties to condense the expression. So this time, we're taking it from the expanded form and condensing it down. Well, on this one, we've got 2 log base 2 of x plus 3. And so really this time we're going backwards. We're going backwards on this. So now I can take this number that's multiplied in front and raise it up as an exponent. So this could be rewritten as log base 2 of, let me write that a little better. That can be rewritten as log base 2 times x plus 3, that whole expression, raised up to the second power. All right? So there's that. Let's see. What about the next one? Okay. That's the natural log of a difference, remember? And then so that can be written as 1 natural log. All right. It can be written as 1 quotient, x minus 2 over x plus 2. And we're done with that one. And so again, it's just kind of using this quotient property backwards. It is a difference. We can just write it as a quotient. Okay. And for the last one, let's see what we've got here. All right, so on this last one, the first thing that I would do here is kind of attack the parentheses or this bracket first. So I'm going to write natural log of x back the way it is, minus, all right, 2. All right, so let's attack this inside part of the bracket. So here, this is a sum, right? So it can be rewritten as 1 natural log and a product. So I'm going to open a set of parentheses and go natural log, and that's going to be the product of x plus 2 times x minus 2. All right? And so I can put those together. I probably could use a bracket like they did if I want to, but I'm using double parentheses. Either one is acceptable, really. All right? And so from here now I can continue to simplify this thing down. And so now I can go natural log of x. And so here I can expand this out by multiplying these together, these two binomials together. And when I do, I'm going to have this. It's going to be minus, and it's going to be still 2. Then it's going to be the natural log of whatever that product is. So x times x is x squared. Then I've got 2x minus 2x, right? So that's gone. And then 2 times negative 2, which is negative 4. And so now, in order to finish it, this is a difference, right? So I can write it as 1 quotient. So that'll be the natural log of, let's see, the natural log of, top number is x. And then my bottom number is, I'm going to put x squared minus 4. Okay? And then I'm going to take this number and write it as the exponent. So that would be x squared minus 4 raised up to the second power. All right, so you'll be using those properties of logarithms to help you simplify, either expand or condense expressions on your quiz as well. And that's all I got for this lesson.